Welcome to section 3. In section 3, we're going to go through IPv6 addressing, how it is structured, what type of addresses are there in IPv6, and how we can deal with it. Are you ready? Let's get started. For the first video of this section, I'm going to show you how this 128-bit address is organized and how you can show it. Let's go. Before we get into the IPv6 structure, I want to show you a timeline which is related to Internet Protocol or IP. It was around 1980 that IPv4 introduced under RFC 791. After 10 years, the concerns about the IPv4 space exhaustion started. So we needed a solution. First, some short-term solutions introduced, NAT and CIDR. By introduction of these short-term solutions, the need for another version of IP differed. However, IPv6 RFCs introduced meanwhile. After 2010, IANA assigned the last /8 block of IPv4, and in 2015, IRENE, as the North America agency, assigned the last IPv4 block. Therefore, some big companies migrated to IPv6. And now we have both versions in internet and maybe in some internal networks as well. But nobody knows when will we completely migrate to IPv6 and get rid of IPv4. This is IPv6 header. In contrast to IPv4 header, as you can see, it has less fields. Therefore, devices can process this header easier than IPv4. If we go through the different fields, we will understand that most of them are the same as the IPv4, except the names has been changed. Version, just like the IPv4 header, shows the packet version or IP version, which is 6 for IPv6 obviously. Class is just like the differentiated services in IPv4 header, and it's used for classifying different types of packets. Flow label is a kind of new field, which is used for different purposes like preventing reordering the packets when we have multipath or detecting the spoofed packets. Payload length, just like the packet length, shows the payload length of the packet. Next header is just like the protocol header in IPv4 and mostly shows the transport layer protocol. Hop limit is just like the TTL field in IPv4 and we can use it for preventing loops in routing structure. Source IP address and destination IP address same as IPv4, except this time our addresses are 128 bits. This is a sample IPv6 address. As I mentioned before, each IPv6 address has 128 bits, and we use hexadecimal values to show these addresses. Therefore, to represent 128 bits with hexadecimal values, we need 32 of them. These 32 characters are organized 4 by 4, and between each 4 characters, we use colons, as you can see in the slide. Each group of 4 characters is called a quartet, but quartet is not a formal terminology, and you cannot find it in IPv6 RFCs, but we use it for simplicity. In general, IPv6 can provide address space of 2 powered by 128 or roughly 3.4 by 10 powered by 38, and it is a huge address space. You may ask, is there any way or method that we can abbreviate IPv6 representation or configuration? The answer is yes, but only in circumstances that you have leading zeros in quartets or quartets with all zeros. Generally, you can use 3 rules to abbreviate IPv6 in these circumstances. First one is you can remove leading zeros in a quartet. The second one is replace all zeros quartets with 1 0. And the last one is you can replace consecutive all zeros quartets with double colon. Therefore, for the address that we used it in the previous slide, the abbreviated form could be like this. Look at the first quartet, FE00. The zeros are not leading zeros, so we cannot remove them, and we have to write them down. FE00, instead of all zeros we have in the quartet, we replace it with 1 0, and do the same for all other quartets with all zeros. And as you can see, we remove double zeros from 00 CD quartet, and we just write down CD, same as the last quartet. We remove all 3 leading zeros and just write down 1. And one more step, for more abbreviation, it could be like this. FE00, 0, 1, 2, 3, double colon, instead of all 3 0 quartets, and write down the rest. Remember that you can use rule 3 only one time. For example, you cannot write this address like this, FE00, double colon, 1, 2, 3, 4, double colon, CD1. It's not possible, because you cannot understand how many zeros were used in the first one, you remove it, and how many zeros were there in the second one. IPv6 logical structure is just like the IPv4 logical structure, and it divides into 2 parts. The first part shows the network ID and the second part shows the host ID. And we use prefix to represent the network ID part and host to represent the host ID part. But this time, these 2 parts together should be 128 bits. And to represent the subnet mask for IPv6, we can only use the prefix notation method, and there is no any other method to represent subnet mask for IPv6, either in representation or configuration.